Assalamualaikum and hi to all panels. My name is Arisya binti Abd Haris. I am from Fibre and I would like to present my PSM1. My supervisor is Dr. Binti Abd Rashid and the title of my PSM is The Effects of Kenaf Fibre Length on Compression Properties of Thermal Bonded Kenaf Nonwoven Web for Mattress Fibre. First, I will introduce you to the background of my study. In recent years, due to worldwide environmental concern, a greater understanding of renewable green resources has raised the manufacturer awareness to conserve the environment, because we can see that the usage of natural fiber for nonwoven product application has increased rapidly in market. So, this study is based on one of the plant species natural fiber named Kenaf. The Kenaf fiber is employed as a raw material for the production of nonwoven mattress filler, which its function is to alter the filler durability as the mattress layer, because we can see that these days the production of mattress filler materials has made from natural plants has increased. The process of producing the Kenaf fiber based mattress filler in this study is by utilizing the air web forming method and thermal bonding process respectively. When selecting a natural fiber for particular applications such as producing a nonwoven, the fiber strength is the very first thing to consider. It is essential to consider the size, flaws, strength, variability as well as structure of the fiber, because the properties can affect how effectively the performance of the nonwoven will be. So this study will analyze on the use of Kenaf fiber as nonwoven mattress filler material by varying the fiber length in order to determine its effect on the mattress filler compactness and firmness, which may provide the supportive layer to the mattress. The result of the length variation will be used as the observation on the potential of the Kenaf fiber, in which fiber length is the most optimum to achieve the firmness in mattress. Several problems that can be found in this study are mattress of poor quality may cause discomfort to the body. The firm and steady texture of mattress is important to human health, as the bed is where a human rests after a long day full with activities. Despite the fact that industry have already developed the Kenaf-based mattress in the past, there is still less study has been conducted on it, because there were more synthetic materials that have been used as the mattress-based materials. Hence, the mattress created from materials like Kenaf will lack of comfort and firmness performance properties as the physical and mechanical properties. This has not been properly investigated. Thus, a study on the mattress manufacturing process materials parameter using Kenaf and polyester is required in order to produce mattress filler with desired compression performance in order to reach a good firmness in mattress. The current issue faced by Ideco company is that they do not meet the criteria for developing a firm mattress filler. Therefore, this study is needed to analyze the effect of different length on the compactness properties of the mattress filler, so that the finding of the study can contribute to the finding the optimal fiber length that should be used to produce the firmness that they desire. So the objective of this study are to produce thermal bonded Kenaf nonwoven web subjected to different Kenaf fiber length, and to evaluate the physical properties and compression strength of thermal bonded Kenaf nonwoven web for mattress filler. The project scope is listed here. Ideco company was the one that supplied the Kenaf and polyester fiber. The Kenaf fiber were cut into 3 different lengths, which is 25 mm, 20 and 15 mm each. Both Kenaf and polyester fiber were put through the air blade process for the web formation and followed with thermal bonding to form the web fiber. The constant composition of 80 and 20 Kenaf polyester was used. Physical analysis such as the test for thickness, aerial weight, density and porosity were conducted on the nonwoven web produced, as well as the compression strength test to evaluate the physical qualities of the nonwoven web that produced. This study is significant in a number of ways, including its potential to reduce the amount of synthetic fiber used in mattress production material, so contributing to the preservation of a healthier environment for future generations. The contribution fall into 3 sectors: environmental, industrial and public sector. The utilization of Kenaf for the mattress filler material at mattress factory in Malaysia will increase the Kenaf production in our country because of rising demand, making Malaysia a country with low carbon footprint and efficient use of resources. use of Kenaf-based material makes the mattress manufacturing company is a resourceful company because they do not depend on familiar material only. Most importantly, the study provides funding regarding the influence of fiber length on the compactness properties in Ideco mattress. The compression strength of each nonwoven web samples with different length can discover the strength and durability possessed by the samples. Then, in public sector, which has the indirect purpose in ensuring the long-term viability of the environmental through the use of natural sources that is restored and replanted upon harvesting as the material in mattress production. Since metals are essential to people, there will be always a demand for them, so the creation from metals made from natural sources will always be beneficial for the population. This literature review presents a summary of the major issues involved in doing this study. The main material used in this study is Kenaf fiber. Kenaf is a fibrous plant that is deep, strong, and tough, as well as insecticide resistant. Kenaf has stem that is unbranched, solitary, and completely straight. And this plant is from bast fiber categories of natural fiber and has been cultivated widely in Africa, Asia, America, and part of Europe for a few thousand years. In a variety of climates, Kenaf can grow to a height of over 3 meters and has a base diameter of 3 to 5 cm in just 3 months after sowing the seed. The fibers of the Kenaf located in its bark, core, and pits. According to Ezekiel's study in his journal, Kenaf bast fiber has understanding, flexural, and tensile strength, so that being a reason why Kenaf bast fiber is chosen for a wide range of processing materials such as extruded, molded, and nonwoven products. Kenaf has been commercially cultivated in Malaysia despite the Malaysian sandy soil conditions that made the cultivation a bit difficult. To produce the best productivity of Kenaf in Malaysia's tropical climate, it requires many fertilizers for the plant's growing. So, Akbar Basri has found that adding chicken feces to the soil instead of fertilizer can satisfy the plant's need while lessen the cost and the environmental impact. And a research concluded by Hadi state that by manipulating planting and harvesting dates, fertilizer types, pesticide application, and crop density can increase the Kenaf production. In textile industry, nonwoven refers to the fabric made of fibrous web kept together by a bonding agent. According to American Society for Textile Materials, nonwoven is a textile structure made by connecting or interlocking fiber, or both by mechanical, chemical, thermal, solvent, or combination of those. Nonwoven production complete in a single continuous process from raw material to finished product. Fiber and bond properties play a role in determining the assembly behavior of nonwoven web. Structure of nonwoven is characterized by its orientation distribution function and as well as consistency in weight that is mass per unit area. There are 3 stages of nonwoven manufacturing process, which are web formation, web bonding, and finishing stage. Nonwoven web is a long, continuous piece of material that is usually moved through a process using rollers. Methods for the production webs include cutting, wet blunt, wet laying, and allaying process respectively. After formation of webs, the webs will be going through process of bonding that are divided into 3 categories, which are mechanical, chemical, or thermal process. Many research have been carried out by modifying structure of nonwoven by using different fiber length. Technically, the length of the fiber is a crucial component of the raw material used in the manufacturing of nonwoven web because fiber characteristics has the potential to affect the strength, solidity, and permeability and woodability properties of the nonwoven. The fiber length is regarded as one of the most influential factors on the tribological behavior of short fiber because it plays a crucial role in formation of interfacial adhesion. In Pastana's study, the short fiber of 2 mm to 4 mm length in high-dose composite demonstrated very low efficiency in both stiffness and tensile strength. Meanwhile, in Misaria's study, it was discovered that the composite highest impact qualities are found at 20 mm fiber length, as well as the highest tensile strength found at 15 mm fiber length. These studies may come to the conclusion that under compressive load, the longer fiber tends to have higher compressive strength than shorter fiber. Mattress is a comfortable sleeping medium for humans. For a restful night's sleep, it is essential that the mattress firmness to relieve or reduce pain and stress in the body. Based on past studies on mattress relation to human, there was a variation in the amount of energy necessary to sleep based on the type of mattress used, and those who slept without a mattress displayed a more restless response. The study revealed that the quality of mattress is an important aspect for the sleeping environment. For the texture, the best mattress should be neither too soft or too firm, since research has established a strong association between the pressure factors, particularly on the buttocks, hands, and whole body pressure, which will perceive both the firmness and comfort of the mattress. To conclude this chapter, by analyzing the outcome of the previous research in this chapter review, the study analyzed a method for determining the optimal fiber length parameters for blending the natural and synthetic fiber in order to produce the non-woven web fillers that are compact and firm for the mattress production. In methodology, this chapter emphasized on the overall process of the study. The first chart shows the overall process involved. From the beginning, the fiber is received from Indigo company, then the fiber will be cut into three different lengths, which is 15 mm, 20 and 55 mm, before undergo the A-late process for the web formation, following with thermal bonding process to produce 3 samples of the non-woven mattress filler. Then, each of the samples produced will be undergone several testing, which are aerial weight test, thickness test, density test, porosity test, and compression test to observe their physical and mechanical properties. The specification of the aerial weight test is shown in the table in the next slide. This study consists of 5 testing, which are web aerial weight, web thickness, web density, web porosity, and compression testing to analyze the produced Kenaf polyester nonwoven web properties when using different fiber lengths. The aerial weight test refers to the mass or weight of fiber per unit area. In order to measure the area of the nonwoven sample, 5 pieces of each sample were cut into square size before processed in weighing each of them separately using a calibrated balance. The area then will be calculated using the formula in the table. To measure the thickness of the web, the sample must be pressed with 2 kPa force to demonstrate how thickness varies with pressure. The standard method for this test is ASTM D5199, and the formula is given in the table. In web density testing, the equipment used is balance and a scale. The testing is referred to the standard method ASTM D3776. The density will be calculated using the formula in the table, which is the density equal to mass divided by volume. The next testing is porosity. This testing will be done using profile projector to read the sample pore size under the lens. This testing refers to the ASTM D73796 standard method, and the porosity will be calculated using the equation. Lastly, the compression test. This test is aimed to study the sample of web behaviors such as strength and ability to recover to its original shape. After a certain force applied onto it, a flat and circular clamp will be used to investigate the compressibility, tenderness loss, as well as the compression recovery of the sample. This test is referred to the standard method ASTM D647100. To conclude this presentation, the tests conducted in this study are expected to provide information in terms of modification that can be made to the length of Kenaf fiber for using in the production of a dense and compact nonwoven web. At the same time, this study is also expected to be able to find out the new features of hybridization of Kenaf fiber and polyester in its mechanical structure when the change of length of Kenaf fiber is performed on it. This here shows my reference in this presentation slide. This is my Gantt chart, and I think that is all from me. Thank you.